This homework, I've got the odd one, so that means number 1 is mine. Let me get my pen ready here to work. Shows here that I'm dealing with an account. When I deal with an account, we said that's like in a bank, right? We're always going to deal with I equals pretty. That's our formula that we're going to use. And that's because I equals pretty stands for the interest that I make in a bank is equal to the principal. And the principal is the loan that I take or the deposit that I make in a bank, right? Times the rate, and the rate is the percent the bank's giving me, and then times the time in reference to years, right? So when this one here, I'm going to have 700 as my principal. I'm going to multiply that to 3%. I have to turn that 3% into a decimal for me to be able to multiply it to numbers. So I'll have to move the decimal place over twice. That's the rule for turning it to a decimal, and it becomes 0.03. So right now, so far, I have 700 times 0.03, and then the number of years is 4, so the time is 4. Now I just multiply everything together. I know that 7 times 3 is 21. I would normally put then that 700 times 3 would be 21 with 2 zeros, but I realize since I have 2 decimal places here, I'm going to have to go 2 decimal places here, which is going to turn it right back to 21. You could check that with the calculator if you like. 700 times 0.03 should be 21. And now I've got to multiply 21 times 4. Remember, I multiplied these two numbers. I did nothing with 4 so far. 21 times 4 is 84. So the interest should be $84. And the answer is $84. Number 3 is a little more difficult because we have a decimal here. So let's go ahead and work that in. I'm going to use the same formula that we had up here. So I'm just going to erase all this. Give myself a little room to work. This time the principal is going to be 480. And I'm going to have to multiply it to 1.5%. And I'm going to have to move that decimal 2 places. So it's going to become 0.015. So this is times 0.015. Then I'm going to have to multiply it to 5 years, so 5. All right, I'm going to do the math over here because it's going to be a little bit harder. 480 times, well, we'll just go 0.015. In fact, let's just do it to 5 first because we'll deal with that decimal later. So I'm multiplying 480 times 5 this time. And leaving the 1.015 later. So times 5. 0 times 5 is 0. 8 times 5 is 40. So I can put a 0 there and carry the 4. And I could take 4 times 5, that's 20, plus 4 make 24. So far I've got 2,400. And remember, I multiplied 5 times 480, so the only number left to multiply there is 0.015. All right, so I'm going to do that work over here, 2,400 times 0.015. I know 0 times 5 is 0. 0 times 5 is 0 again. 4 times 5 is 20. carry the 2. 2 times 5 is 10, plus 2 make 12. On my next one, I need to put a 0 into the first one. And since it's to 1, I can literally put all the numbers there because I know anything times 1 is itself. So 1 times 0 is 0. 1 times 0 is 0 again. 1 times 4 is 4. And 1 times 2 is 2. I'm going to add the two numbers together. You might be saying, Mr. Mendez, why didn't you multiply everything to that last set of numbers? But remember, the last number was 0. So basically, if I chose to do that, every number would be 0 anyway. So why even bother? 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. Then I have 2 plus 4, that's 6. I have 1 plus 2, that's 3. Now I have to remember there are 3 decimal places, 1, 2, 3 here. So I have to move my decimal place 1, 2, 3, and put it here. That means the actual number is 36. So all this is equal to $36. Let's check and see how we did. $36 is the answer for number 3. I'm going to give you a little clue about number 4, just to make sure you remember what we were taught in class. And I'm not going to work it. I'm just going to give you a clue here. Remember, in reference to time, I'm talking about 30 months here, everything has to be in reference to years. So when it tells you that you're doing 30 months, you're going to have to take 30 months, right, out of, let's see, 30 months out of, I would say, the number of months in a year. So we realized that the number of months in a year is 12. So we would have to put 30 over 12 as representing our years. So we would multiply our principal times our rate after we move the decimal twice, and then we'd multiply it to 30, and then we would divide it by 12, okay? Because this number every fraction a division problem. All right, so that's going to be a little tricky, but try to remember that. All right, next is number 5. Write the indicated ratio, and then find and interpret the value of the ratio. Well, it says the ratio is rolled oats to chopped peanuts. When I look at this, I see that rolled oats is 2. Chopped peanuts is 1/2. So that's a ratio of 2 to 1/2. It says, then find and interpret the value of the ratio. Remember, this is going to be 2 divided by 1/2. We have to use keep, change, flip for this, right? So this is going to be equal to 2. Instead of dividing by 1/2, we'll multiply by, remember, we keep the top number the same, keep. Change, which means we change from division to multiplication. That's what the dot is. And then we flip the second one. So this would be 2 over 1. And this would be going to be 4. Find and interpret the value of the ratio. So for every 1 cup of chopped peanuts, 4 cups of rolled oats, right? Let's see how we did with that. 2 to 1, the amount of rolled oats in a recipe is 4 times, that what you got there, 4 times the amount of chopped peanuts. All right, let's go to number 7. You have number 6 to do. Pumpkin seeds to rolled oats. Pumpkin seeds is going to be 1/4. So I think I'll do the work over here for number 7. Gives me a little more space. 1/4. And then rolled oats. Let's see, pumpkin seeds was 1/4. Rolled oats be 2. And that means we would turn this into a fraction, 1/4 over 2. This fraction means we're dividing, and the only way to divide when you have a fraction up top is to turn it, it's use keep, change, flip, right? So this turns to 1/4. We're keeping the top number the same. We're changing from division to multiplication again, and we're flipping the second one. So instead of it being 2, which is really 2 over 1, it's going to become 1 over 2. Now I have 1 times 1, that equals 1. Now I have 2 times 4, and that equals 8. Right? So what is this telling me? It's telling me that, remember we're dealing with number 7 here, right? That we're going to have 1/8 pumpkin seeds, okay, for every 1 oats, right? For 1 rolled oats, for 1 cup of rolled oats, excuse me, 1 cup it says here, we'll have 1/8 cup of pumpkin seeds. Let's check our answer. 1/4 to 2, the amount of pumpkin seeds in the recipe is 1/8. That's what we got. The amount of rolled oats. All right, let's move on to number 9. Number 9 says graph the solution when I graph b minus 2 is greater than or equal to -7. I remember that I have to find the value of b, which means I got to isolate b. All my numbers that I can combine need to come to the other side. So to get rid of a -2, I'll add 2. I'm sorry, I'm going to have to move this here. I'm going to reveal the answer that I want everyone to see here. I have to add 2 to this side, which means I have to add 2 over here. The b comes down. The inequality symbol comes down. Now remember that when my -7 and 2 is like I borrow $7 from somebody and I pay them back too, right? So that means I'm going to still owe them $5, -5. We remember when my signs are different, right? I have a negative and a positive, I find the difference. That's the answer to a subtraction problem. So I knew I was going to subtract. I take the big number, 7, I minus the small number, 2. That gave me 5. And then I have to keep the sign of the big number. The bigger number was 7. It had a negative in front. That's why we had -5. That's how we have b is greater than or equal to -5. Now I have to remember, since b can be equal to it, I'm going to shade in my dot there. And then all the numbers that are bigger than -5, that means all the numbers to the right of my number line, right? So that's why this dark shade is pointed with the arrow in this direction. All right, let's try number 11. 6 is less than or equal to -2g. Once again, I have to get all the numbers to the opposite side of my letter. I remember that -2 is being multiplied to g, and I have to do the opposite. Just like over here, I do the opposite of subtracting 2, I added 2. This time, since I'm multiplying -2 to g, I'm going to divide -2 away. Whatever I divide from one side, I have to divide from the other. 6 divided by -2 is -3. I know this because 6 divided by 2 is 3, and I know a positive, and that's what the 6 is, a positive 6, divided by a negative number makes a negative number. Now, -2 divided by -2 made 1, so now I have 1g left over here. I would normally just bring my inequality symbol down, but the rule says whenever I multiply or divide by a negative number, I have to take my inequality symbol and turn it in the other direction to make my answer right. So now -3 is bigger than or equal to g. If I was going to make my graph, and I'm going to make it over here, I would put -3 on the bottom. I would remember, since it's a line under here, I'm going to shade in my dot. If there was not a line, I would make it an open circle to not include the number. But in this case, since it does also equal it, I'm shading in it to include -3. And since I'm sorry, G is smaller than, right? Because this is saying -3 is bigger or equal to G. So that means G is smaller than -3. Then I've got to shade in all the numbers, right, that are smaller than -3. Smaller means to the left of my number line. So my arrow will go in this direction. Let's see how I do. It shows here G is smaller than or equal to -3. That's what we got here. G is smaller than or equal to -3. They put a dot at -3 like we did, and we put an arrow pointing in this direction to all the numbers smaller. All right, number 13 is next for me. It says determine which numbers you are more likely to spin and which numbers you are less likely to spin. Explain your reasoning. Well, we're talking about which numbers here, right? And these are all equal sides. Every one of these looks exactly the same. Unlike over here, where you could tell it's probably more likely you're going to land on 4 and 2 and 5 because they're bigger spots than you would on 1, 6, and 3. But over here, since all of them are the same, you have an equal likely chance of landing on every one of these because the ratio, the area of each of these is the same. Okay? So equal chance. All numbers have the same area, so you are equally likely to spin each number. All right, let's move on to number 15. Number 15 says, identify the outcomes, you spin the spinner shown. Okay, looks like all of the sides have equal chance of landing on it. It says, what are the favorable outcomes of spinning a number no greater than 3? No greater than 3, okay. No greater than 3 means that it can't be bigger than 3, right? So it can be smaller than 3, and it can be equal to 3. So we're talking 1, 2, 3, right, out of 8. So this would be a ratio of, well, let's see, favorable outcomes of spinning a number no greater than 3. That'd be 3 out of 8 times. I would put 3 eighths. So you have 1, 2, and 3. Those are the favorable outcomes, right? 1, 2, and 3. 3 out of those 8. 1, 2, 3 numbers, okay? Then it says, in how many ways, remember you have 16, in how many ways can spinning a prime number occur? All right, if I'm spinning a prime number. A prime number is a number that no number goes into, right? Let's say like the number 8. I know 4 times 2 is 8, so 8 is not prime. But it says how many ways can spinning a prime number occur? So we're looking for all the ones that are prime numbers. I know 1 is a prime number, right? 2 is a prime number. 3 is a prime number. 4 is not because 2 times 2 is 4. 5 is a prime number. 6 is not a prime number because I know 3 times 2 is 6. And prime means no 2 numbers, with the exception of 1, of course, can go into it. All right. 7 is a prime number. 8 is not. So prime numbers, let's say we have 1, 2, 3, 5, and 7. So there are 4 ways, right? 1, 2, 3, 5. Actually, that's 5. And how many ways can spinning a prime number occur? And they say 4 ways. I'm thinking that they believe that 1 is not a prime number. So they must be counting, they must be counting just 2, 3, 5, and 7 as my prime numbers. I guess I would disagree and think 1 is. I'm going to look it up just before I change this answer because I hate giving you the wrong answer. I did look it up and I found out that I had a misconception. 1 is not a prime number. Prime number is bigger than 1. I guess that's why it doesn't include 1. So that would have left 2, 3, 5, and 7 as my prime numbers. So yes, they're right, 4 ways. I apologize for that. I learned something new tonight. All right, let's go to number 19. Let's see. You randomly choose 1 marble from the bag. Find the number of ways the event can occur. All right, so that's the first part. How many ways can the event occur if I pull 1 marble from the bag? Well, for 19, it says choose a green one. There's only 1 green one, and it's 1 green out of, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have a 1 out of 9 chance, right? 1 out of 9 chance that it will be green. Then it says find the favorable outcomes of the event. Choosing 1 marble from the bag, okay? Find the number of ways the event can occur. I guess just 1 green, right? And the favorable outcomes would be 1 out of the 3, 4, 5, 6, 7, 8, 9. 1 out of 9? Yes, 1 out of 9. So 1 way, right? 1 out of 9, 1 way, and it would be green, and that's the favorable outcome of the event, a green. All right, let's look at number 21, choosing a yellow one. And again, we have only 1 yellow one, so I think we're going to get the same answer here, right? This time it would be 1 way again, but this time the favorable outcome would be yellow. And as you can see, we have, this kind of went backwards, didn't it? Because B was supposed to be yellow. So I'm going to correct this and say that this A should have been 1 way. And as you can see, it says B here, right? B should have been yellow, right? So A, 1 way. And B, yellow. All right, let's go to number 23. Choosing not blue. Okay, not blue. Well, not blue would mean it could be purple, right? It could be this red one, this red one, this red one. It could be this yellow one, this blue one, or this green one. So there's only, oh, I'm sorry, it couldn't be the blue ones. Let's go back and erase those. It said not blue. So it could, in fact, be this purple one. So not blue. We have 1, 2, 3, 4, 5, 6, 7 ways, right? 7 ways. And then, well, the colors could be purple, right? There's 2 different purples. There's 3 different reds, and then a yellow and a green. So 7 ways. It can be red, red. We said, oh, red, red, red. We said there were 3 reds. 2 purples, right? Purple, purple. And we said 1 green and 1 yellow. Those are our favorable outcomes. All right, let's go to number 24 now, or 25. You have number 24 to do. Discuss mathematically. Tell whether the statement is true or false. If it is false, change the italicized word to make the statement true. Okay. Spinning blue and spinning green have the same number of favorable outcomes on spinner A. Okay, we're going to have to find the spinner to see how this is going to work. So give me a second here. Okay, I found the spinner and put it in there. I'm glad I did because I would have needed it for the classroom too. Now remember, it says tell whether the statement is true or false. If it is false, change the italicized word to make the statement true. All right, it says spinning blue and spinning green have the same number of favorable outcomes on spinner A. So let's see, spinning blue and spinning green. Green, there's only 1 out of 1, 2, 3, 4, 5 chances. And blue, there's 2 out of 5 chances. So I would say this is false, right? And change italicized word. I'm going to have to look for the italicized words now because I don't see them here. Hold on. All right, change them. A lot going on with this PowerPoint. I'm glad that I got the corrections before I taught it. The italicized word is green. So it says, to whether the statement is true or false. So spinning blue and spinning green have the same. Well, that's not true. But I would say if I had to change the word green, I could put it to red, right? Spinning blue and spinning red have the same number of favorable outcomes. So false and red. For number 26, it's you to do. Number 27, spin red can occur in 4 ways on spinner B. Well, I'm going to have to find spinner B now. Oh, my goodness. And now I found spinner B, and it says, now I have 27. Spinning red can occur in 4 ways on spinner B. All right, spinning red. 1, 2, 3, 4. That's true. It can occur 4 different ways. So that is true. You have number 28 to do. I'm going to go to number 29. Hope there's no more deviations in the slide. Number 29 says, describe the likelihood of an event given its probability. Your soccer team wins 3 out of 4. 3 out of 4, 3/4 of the time. Your soccer team wins 3/4 of the time. Okay. Describing the likelihood of an event. Let's see if there's anything I'm missing here because I don't see where I would even be able to. Oh, I see. Describe the likelihood. Okay. Is this likely if your soccer team wins 3/4 of the time? Yes. The likelihood is, it is likely, right? Maybe not extremely likely, but I would say it is likely, it might even be very likely, being 3/4 of the time, that you will win. So likely. Number 30 is for you to do. Number 31. The probability that the sun rises tomorrow is 1. Now remember, 1 as a percent is 100%. So I would say this is absolutely true. It is certain, right? Yeah, with 100% certainty, I would say that the sun is going to rise tomorrow. And for those that didn't understand what I said by turning to 100%, remember, to turn a percent, let's just say like 100%, into a decimal, I have to move my decimal 2 places, which makes it 1. So to turn a 1 into a percent, I would move it 2 decimals in the other direction, 2 decimal places, and that's 100% certainty, right? Number 32 is yours to do. Number 33 says you have 50% of being chosen. You have a 50% chance, excuse me, of being chosen to explain a math problem and a 32% chance of being chosen to explain a science problem in front of the class, all right? Describe the likelihood that you are chosen to explain the math problem and the likelihood that you are chosen to explain the science problem. Well, you have a 50-50 chance, right? You have an equal chance of being chosen to do the math problem as you would not be chosen. But with the science problem, you are more likely to be chosen to not, or to not be chosen, right, of being chosen to do the science problem, then you would not be chosen. So you would say that you are not likely, right? So my answers would be equally likely to be chosen or not chosen, that was for math, and unlikely to be chosen for science, right? Equally likely or to be chosen or not chosen, 50-50 chance, equal, right? And then unlikely because there's more of a chance you're not going to get chosen for your science, right? And B says, your friend says that you are likely to be chosen to explain the math problem, because you have a greater chance of being chosen to explain the math problem than the science problem. Is your friend's claim reasonable? No. Being chosen to explain the math problem and being chosen to explain the science problem are two separate events, right? So they have nothing to do with each other. Your friend is incorrect there. Number 20 or 34 is for you to do, okay? And let's see. That's it. So good luck with the rest of your homework. I'll see you in class for grading, and have a great night.